All right, example 4, we're going to integrate 1 plus cosine of x over sine of x dx. We don't want to use a u sub here for the denominator because the derivative of sine of x is cosine of x, and we have a 1 plus cosine of x, so we just can't create that out of thin air. So the best thing to do here is to break this into two fractions. We're going to change this to 1 over sine of x plus cosine of x over sine of x. And now what we can do is we can use some of your trig identities. 1 over sine of x, that's cosecant of x. Cosine x over sine of x is cotangent of x. And we'll write these as two separate integrals and integrate them separately. Next, if you don't recall, we'll go over to our table. Ding. Cosecant of x, I believe there it is, number 15. So that'll be the natural log of the absolute value of cosecant x minus cotangent of x, close it up, plus c, and cotangent is the natural log of sine of x plus c. So stealing those off of our integration table, there's our first one, there's our second one with our plus c. Example 5, we want to integrate x times the binomial 1 plus 1 over x to the third power dx. We kind of saw this in our last unit. We'd have to FOIL this out. If I FOIL that out, it's 1 plus 3 times 1 over x plus 3 times 1 over x squared plus 1 times 1 over x cubed. Then we'll distribute the x to everybody, and in doing so, that will cancel the x here, change this x to x to the first, this one to x squared, which we're going to change that to x to the negative 2 power. We'll just use the power rule. 1 over x, we'll save that for our natural log. So integrating x, we get x squared over 2 plus a 3x plus 3 times the natural log of the absolute value of x. Add 1 makes it x to the negative 1, dividing by negative 1, it's a minus x to the negative 1, or 1 over x plus c. Example 6, you have 1 over x squared minus 4x plus 9. We can't do the natural log. Think about the derivative of x squared. It would be 2x, and there's no 2x in the numerator. So what I'm thinking about here is looking back at your table. Here you have 1 over an x squared. Here you have x squared. Here's an x squared right here, plus a constant squared. So what I'm going to do is I'm going to manipulate the bottom to make it look like two terms being squared and added together, which means we're going to complete the square. So we're going to make this look like number 17 here. So completing the square, x squared minus 4x plus something, take the 9 outside, and then we're going to subtract something. We're going to add something over here to the left, but then we're going to subtract something over here. So to complete the square, we take half of negative 4, which is negative 2. We square that, and we get a 4. So this becomes the binomial x minus 2 squared. That's going to be your u squared, if you will. The plus 5, that's going to be my a squared. So I'm going to change this to the square root of 5 squared, and now everything fits here. This is the a, this is the u. And again, I'll be honest, it doesn't matter which order they come in because you're adding, so we can switch it around. So my answer is going to be 1 over a, so a being the square root of 5. 1 over the square root of 5 times the inverse tangent of u. Okay, that's going to be this right here. We're going to take the square root of all that, which is the x minus 2. All right, right here. And then we'll put it over the a, which is just the square root of 5 plus c. Example 7, sine of x over the square root of cosine of x. This is going to be a good u sub here. Look to the denominator. Let's let cosine of x be my u. That way, the cosine of x, its derivative is negative sine of x dx. We'll divide the negative over, then you have your sine x dx right there. So this becomes negative, that's the negative off the du, 1 over the square root of u, which we can now write that as u to the negative 1/2 power. Use your power rule like we did the last couple class periods. Add 1, divide by 1/2, which means multiply by its reciprocal 2. So negative 2 u to the 1/2 plus c. Now replace u with cosine of x. We'll put it back inside of our square root of x, or square root of cosine x, excuse me, back inside the square root sign. That's the 1/2 power. And there's my answer. All right, example number 8, we have e to the 1 over x all over x squared dx. This one looks so confusing because you have two different functions, base e exponential and an x squared. What I don't like right here is I don't like this 1 over x. I'm going to change this to x to the negative 1 power. And then this x squared being in the denominator, that's x to the negative 2 power. So when I rewrite it, now you're going to see, okay, who is the biggest power? X to the negative 1. What's its derivative? Would be x to the negative 2. That's a u sub. We'll let x to the negative 1 be the u. Take its derivative, subtract 1, and then it'd be negative 2 that you need to, or excuse me, take the negative 1, multiply it to the front, divide over the negative 1, and here's my x to the negative 2 dx. So my negative, I'll put that in front, and I'll have the negative integral e to the u du, and we know when you integrate e to the u, we found out that's just e to the u. We'll multiply our negative to it, plus the c, and now grab that x to the negative 1, put it back in for u, or change that back to e to the 1 over x. Example number 9, we're going to integrate 2 over 3 secant of x minus 1. First things first, get rid of the 2/3. Factor that to the front. Now you can check that table again, but we don't have any trig rules with a secant minus 1 in the denominator. So I need to do some manipulating. And you're going to see a lot of trig functions with a plus 1 or a minus 1 somewhere within the binomial. Think conjugates. We want to multiply the top and the bottom by the conjugate of secant of x minus 1. So that's secant x plus 1. Because when you multiply these conjugate pairs, it's going to cancel the middle terms. You're going to end up with squared terms, and that's going to lead to your Pythagorean identities. So here I'll have secant of x plus 1 on the top, secant squared x minus 1 on the bottom, and that's the Pythagorean identity, which is secant squared x minus 1 is equal to tangent squared x. So I subbed it out. Again, like we saw with the other trig fraction, we'll write this as two fractions, secant of x over tangent squared x plus 1 over tangent squared x. So again, some simplifying here. I'm going to break this apart. Secant of x is 1 over cosine of x times 1 over tangent squared of x is cotangent squared x. So that puts cosine squared x over sine squared x. 1 over tangent squared x, again, cotangent squared x. We can do some canceling of the cosines. So I'll separate sine squared x as two separate sines. So now 1 over sine is cosecant of x. Cosine x over sine x, we said was cotangent x. And then we have plus cotangent squared x. But again, as you look and take a peek at your integration of your trig functions, you're going to notice there is no cotangent squared there. So using your Pythagorean identity, cotangent squared x, if we go back up here, secant squared x minus 1 is tangent squared x. So your identity is cosecant squared x minus 1 for when you have a cotangent squared x. Now I do have a cosecant squared on my identity sheet. All right, so now that I've altered my function, my fraction, to this here, now I can integrate it, each term individually. If you look through the sheet, number 11 says cosecant u, cotangent u. du. Okay, that's this part. That's supposed to be, looking on my sheet, it says negative cosecant of x. Number 9 is cosecant squared. That says negative cotangent x. Integrate the 1, that's minus x. Add the c. You can distribute to 2/3 if you want, but it's not necessary. So there are some examples of integration rules that you should have seen from Calc 1.